Hello again. Let's bring it all together and show you how it works. So, here's the long way. I do not recommend this, but it's a fun illustration. So, one way to specify a ggplot is to specify every single freaking component that we've seen. So, if you can understand all the pieces, this method is probably the least confusing method to specify a ggplot. However, it is super wordy. It is super verbose. Let me show you. But first I'm going to talk about it apparently. So suppose we want to make a plot with points and some kind of smoother using the diamonds data. We can specify data, mapping, geom, stat, and positions for each layer, along with scales and the coordinate system. Like this. So this is just two layers right here. Where we've got our data is diamonds, mapping is static to X caret, Y price, geom point with stat identity, position identity. Second layer here is using geom smooth, position identity, stat smooth, along with the parameters to use that smoothing function. On top of that, we throw in some scales and logs and do Cartesian coordinates. Here's that plot. Yeah, that's a lot of writing to get this plot. But we can make this so much shorter by leaning on those defaults. So here, we've assigned all the extra, following layers with data and aesthetic. So whatever you put in the ggplot becomes the default for everything. When I say the ggplot, I literally mean the ggplot function. And then we toss on geom point. Then we toss on top of that stat smooth, and then our scales. And it'll look identical. So this code is still pretty long, but way less long because we didn't have to specify the positions or the stats for geom point or the geom for stat smooth, because the default for stat smooth is geom smooth. It's pretty nice. And we didn't have to specify our coordinate system at all. So you can check all of this out here by just summoning the names of the various pieces of our plot and layers. Wow, this was a really short chunk. But yeah, to make that same plot, we can do it the hard way or the easy way. Cool. Okay, so let's do an example. I want to show you Minard's plot of Napoleon's invasion of Russia. Every data visualization class taught by anyone who has any connection to exploratory data analysis teaches this plot because it's really, really cool. You saw it in the other videos in this module. It's everywhere. It's good. There are other variants of it. There are different applications using Hannibal and a couple others. But I want to use Napoleon's because I think it's good. So here is probably one of the most famous statistical graphs ever. It was created by Charles Minard, and it illustrates Napoleon's 1812 invasion of and retreat from Russia. Now it is in French, and I've got an English translation on the next slide, right here. But I want to just highlight that this is the original color scheme right here, and we'll crawl through it. But I want to show you the original. So we got words up there, and here we have a ton of different detail here. Here we've got the starting army, where width is just capturing the volume of troops. We got starting army, we've got the geography underlying it. We've got temperature and direction and time. There's a lot happening. And we can see that a couple of branches of troops came off, and the direction, the advances in this beigey color, and the retreats in black. And so you can see how many troops are left and where they came from. So there was an early branch off here. It's not so great. Um, and so 22,000 branched off, but 6,000 came back. Got a branch here at the around Wilna, 60,000. They hit a river. They get trimmed down. Then they meet back up on the way back. But it really conveys how much happened. But yeah, okay. So let's zoom in on the slightly modernized one so we can read it. Um, so here we've got a figurative map of the successive losses of men of the French army in the Russian campaign, 1812, 1813. The numbers of men are represented by the widths of the colored zone at a rate of 1 millimeter for every 10,000 men. They are further written across the zones. The red designates the men who enter Russia, the black, those who leave it. Served to draw the information which has served to draw up the map has been extracted from the works of M.M. Thiers, de Segur, and all these other people, as well as a unpublished diary of Jacob, the pharmacist of the army, since October 8th or 28th. So in order to better judge with the eye the dimensions of the army, I have assumed the troops of Prince Jerome and the Marshal Davant, who were attached at Minsk and Mogilev and rejoined, had always marched with the army. So they made some simplifying assumptions here, but we've got a map. The rivers show up way better here, so you can kind of see. Here's the first kind of trimming. Yeah. So they detail the simplifying instructions, and you can see when they cross the Orsha here, that there's a pretty big chop down. It's not great, and they rejoin. They lose half when they cross the river. On the ways back, it's not great. Um, Here we've also got a graphical table of the temperature injuries below zero from the Roman the thermometer. And there's like dates and the temperature and things like that. It's pretty neat. And so though there's a ton of information in here. Now this graph was published in 1869, so it's fairly recent in this big scheme of historical things. But it tells a big story, and you can just see the devastation of just the army. Now, I'm not even going to get into the civilian deaths because those were pretty rough, but the point of this plot is it really just shows you so much about what happened in one eyeball, versus if you had to read these deaths in a table, it kind of gets lost on you. So we're gonna plot it. Here's I've got some Minard data, got just the raw troop numbers here. I've also got some dimensions for the cities, and the really basic plot. Now, we're going to go through a couple iterations. But so as a first attempt, let's just plot the troops. So we're going to assign our plot troops. We're going to just throw in our Minard data. That's where we're going to start, and then we're going to add a paths, because those seem like that's the way to do it, right? And then we're going to map our X and Y onto latitude and longitude to get our map. And then we're going to assign direction by color and set the size of our path to survivorship. And then group it by division to like break off those or actually here. No, yeah, so the couple of like branching offs to give us some info. Now this plot's not great. There's a lot of missing. So let's toss on another layer and get some cities so we have a little context. I mean, this plot is not going to be a beautiful Minard plot, but if you want, you can try and modernize it. So yeah, so we have our troop plots. We're going to keep that and all those pieces. And now let's toss on some labels so we actually can see the cities and get a little context. Uh, and so we mapped on our cities with longitude and latitude as a function and labeled them with their city names. And so we've at least have something. We've just tossed on another layer using a separate data set. Okay, so there's still not a lot of greats. There's still room for growth in this plot. Colors would be great if they were red and gray like they were in the original. Maybe we can adjust the line widths to be proportional to the number of survivors. And it'd be really nice if we had like rounded edges just from aesthetics, because it's all like choppy on the corners. Just some thoughts. Okay, so here is an improved version. I didn't go through all the iterations here because I'm lazy, but even this could use some improvement. And we've got geom path, we got geom text. I've adjusted the scaling. I've done some manual typing in here, given it some breaks, just to break down our survivors into at least 3 chunks so we can have something, at least so we can see it. Now, this is a scale that's continuous, but to illustrate, the breaks are there to illustrate various widths. We've also set some colors. We got gray and red. We got the breakings and labels of advance versus retreat. I've cleaned up a lot of the labeling and blanked a lot of the elements. It's still not great. Would be good to like see if we can get some like kind of Google Earth image from this region, or just get a map or something, add another layer underneath. But it's an improvement over that. And that. Well, actually, no, technically these are the same. And that. So your turn. This is an optional activity. I have not fully programmed it in because I just haven't. But I encourage you to try making a histogram with the diamonds data set. So try it starting with this base code, but then rewrite it using the layer functions. So it's a bit of a steep task, but it'll really help cement your knowledge of ggplot. And so when I say layers, I'm talking about, where is that? Oh, all the way back here. This guy, right here. Actually, I think I'm going to smush these together. Cool. Nope, I'm not, because I really want the Minard plots to be by themselves. Oh, life choices. Okay. So your challenge is to rewrite this using the layer function. So if you don't know the default values for a plot, you can look them up and examine your layers. And also remember that a histogram is a plot with stat bin and geombar. That'll help you out. So still your turn. I've generated the plot here using geomapping. Essentially, I just printed out that guy over here. So you can, I recommend trying to, if you want to push kind of a moderate stretch goal, modify your histogram code so that it uses a different geom, like geom line or point, or another one. So this change should be relatively simple once you've gotten into that layer specification of histogram. So in your histogram, you might want to think about adding an aesthetic layer from one of the factor variables, maybe like color or clarity, to the color aesthetic. And it'll help you to also think about what the default position adjustment is for the histogram. Tips include try changing the position adjustment to something like anything else, something different, using position dodge. There's one way. So the bold stretch goal is recreate the Minard map. You're welcome to use the code that I've got in these slides. It is based on many other people's code to try and get it to be close. You'll find a lot of Minard plots out there because it's kind of a good big exercise. And so you're welcome to look at those, but if you do kind of stare at other people's code, try and understand why they made the moves they did and even like comment in what you think is happening as a learning exercise because that'll be really helpful to you. Another piece that you could consider adding is the time and temperature to the bottom of the plot. That last little chunk there that I did not include here. So just wrapping up, remember some of this. I think I included this somewhere else in the lectures. So exploratory data analysis is detective work. As all detective stories remind us, many of the circumstances surrounding a crime are accidental or misleading. Equally, many of the indications to be discerned in bodies of data are accidental or misleading. To accept all appearances as conclusive would be destructively foolish, either in crime detection or data analysis. To fail to detect that, to fail to collect all appearances, because some or even most are only accidents, however, would be a gross misfeasance deserving and often receiving appropriate punishment. So you heard it here first, folks. Tukey is going to go and arrest you if you make bad graphs. Or at least don't try and like plot stuff. You heard it here first. So kind of concluding thought, and this will wrap up. So the flexibility of the grammar of graphics allows us to collect many more kind of appearances in our data and of our data than we would if we had just been access to a handful of named plots. If we only use the classic plots, we're going to miss out on a lot of the nuance of the data because those classic plots aren't designed with your data in mind. They are just easy kind of cookie cutter recipes to get started. So, while many of the plots that we can make with ggplot aren't particularly useful, but the point of making those plots is to try and visualize the data in as many different ways as possible so you can see what is happening in the data. Even the worst plots will tell you something about the data. They'll tell you it's bad or it's boring. Like the plot, when I say bad plots, usually they're boring or like super misleading. Either way, that is still informative for you as you kind of work your way through the visualization and like try and untangle what is happening. So ggplot opens up a huge space in statistical graphics for us with very little effort. I mean, frankly, this entire class is circled around like getting you the tools so that you can make cool graphs with ggplot. Because ggplot is magic. So I'll see y'all later. Bye!